Let's look at Vladivostok here. It's a stack level again. It's definitely a little different from the usual levels. So let's quickly jump over to the code. When I say it's different, usually with stacks you have really long strings. You fuzz the program, destroy stack, return pointer, and jump to shellcode. The concepts are still similar, but the way you approach it is definitely different, and it's pretty interesting. So if you look at main, you see a couple of calls to rand, which basically means generate some kind of random numbers. You see a call to memcopy here. Memcopy is kind of interesting because it's going to copy stuff from one place to another place. What the data is and how much the data is something for you to figure out. And excuse me, in previous levels you've seen calls to log in or some kind of similar function from main, but this time you don't see anything of that sort. We just see this final call to R13, which is basically a register, which means that there's some kind of address inside R13 which your program is going to jump to. So if we quickly run the program till the call, and you see it kind of does some stuff, and it'll eventually break in R13. So you see R13, it's broken at B512. Now it's obviously something in B512. So you see that there's some kind of code at B512, which is what it is calling. And now you remember previous levels, if you want to go into the program, you say S, which is basically a single step, and you'll see this little blue bar like kind of jump around here, like up and down depending on where you're stepping in. So now you're here and you look at program counter, which points to what my next address call is. It's S. It does jump to B512, but interestingly there's nothing displayed here. You see that? There's nothing here. And you can keep doing S. You can see the value of program counter like in the top on the right hand side of the screen here. That keeps changing, which means the program's continuing, but there's nothing here. You can't look at it here. So it becomes a little difficult from a user interface point of view to kind of track this program. But anyway, if we hit C, it does a lot of stuff, and you see what happened there. You see what happened here in the background. Click wait here. You see all of that code? It's all vanished. There's no code there anymore for you to take a look at. If you keep hitting S though, the program's still running, right? So you could still enter stuff here, and it'll take it. But there's nothing for you to see here. There's no way for you to step here. The code's purely running in memory at this point of time. That's what's really happening. So I would suggest you think of a quicker way to do stuff. So how do you actually find out what instructions are actually running? Sure, you can see this. You can see these. This is the next instruction that's running in this little box right here. See all of that? That's the next instruction it's going to run, which is great. But you do want to see. You do want to look at a few instructions in batches. Like you want to look at 10 or 15 instructions together and look at the flow of the program instead of stepping through this instruction by instruction. And this is purely runtime, remember. So I would definitely look at how to handle that funny business of stuff getting completely overwritten. So promptly for a username, and remember you also need a password. Now whatever you print into username here is displayed on the screen. You also need a password here. Let's enter a password. If you exit, so nothing seems to happen. There's a couple of hints that I'd like to give you at this point of time. You remember that I've always been saying when you enter input, find out where it's going into in memory. Do that here as well. So if you reset the program and let's run it one more time, and run C again, so it'll break in the call to R13 one more time. You look at the address for R13 here, it's 85B4, right? Let's run it one more time. So reset it. Remember, it was 85B4 last time. Last time we broke on the call. See that? It's not 85B4 anymore. So the address for R13 is somehow changing in memory. So you need to find out how to get around that. Why is it changing in the first place? What key concept is responsible for causing this change. It's the same thing with the password too. If you look at it, I mean, once you step into that call for R13, it's inside the call to R13 that you're generating those username and those password boxes. The input that you put into the password box is again going to go into a location memory that's going to change every single time. So all of this is due to something called ASLR, or address space layout randomization. There's plenty of stuff out there. I mean, just go to Wikipedia and just read the wiki article for ASLR. That itself will give you quite a lot of information about how ASLR works. And once all of that is done, I would definitely copy the entire assembly offline for quicker reference. I mean, so you look at you notice the entire program is getting overwritten all the time, right? So I would definitely take all of that assembly out and put into a text file and have it outside. While you're debugging inside that call to R13, you definitely want to know what instructions are being called, and you'll need a calculator a lot here to actually calculate addresses and figure out where exactly you want to jump. So keep your assembly handy, keep a hex calculator, just a basic calculator with just addition and subtraction, or if you can do it in your mind, that's fine enough. Do that. And just one final tip at this point of time, that call to R13, right? What function does that actually map to in your main program? What code is that? Have you seen that code before? I would definitely map code in R13, in that call, the function that's getting called, I would definitely map that back to the code that you've already seen in the main program before the entire display got overwritten. And once the function completes, where does that actually return to? If you can figure out all of that, you can figure out the mapping, if you can figure out where it's going to return to, and figure out how you can kind of predict, it's kind of loosely using the word predict there, but kind of predict the addresses for all of the stuff, like the password, the username, where it's going, and where do you want your shellcode to be there, what programs do you, what code do you want to jump to. If you can predict all of that, you'll be pretty close to solving the problem. I mean, I do understand that I'm being a little bit vague here, but just keep these 2 or 3 points in mind. Remember ASLR, figure out how it works, understand where username and password are getting called, and where it's going into in memory, and where your function returns, the call to R13 or the call something inside there, where does it actually return to? Does it actually return to somewhere where your actual inputs are? Figure all of that out, and you should be pretty close to getting this one. Yeah, I mean, definitely use the IRC channel for this one. It is one of the more trickier levels, and I did say that as you go on, it's just going to get harder. So if you get stuck for too long, you're finding difficulty in understanding what ASLR is and how it works in this case, just go to the IRC and put a few questions down there, and someone should answer. If you still get stuck and you have no way to proceed, just ping me. I mean, just shoot me an email, and I'll be happy to kind of help out. All the very best. This is a really fun level though. If you get this, you'll feel really good about yourself. All the best. Bye.